I'm Anil Kumar. We'll discuss domain of a complicated function in this example. The question is, find the domain of f of x equals to square root of x minus 5 divided by x plus 3 times square root of x squared minus 4. You can always pause the video, answer the question, and then look into my suggestion. Now, the domain is basically common domain or intersection. So what is intersection or common to, right? We say common domain. Intersection of domains, right? Of each term. Each term. So we have basically three terms in it. So we are going to analyze each one of them. The first one here is square root of x minus 5. And then we have one term which is 1 over x plus 3. And then we have 1 over square root of x squared minus 4. So these are the three terms. We'll find their individual domains and then we'll find their intersection. Right? So I hope the approach is good. Let's look into these in different ways. We could actually graph these also. Okay. So let me graph this one. X minus 5 basically means that's a square root function moved 5 units to the right. So it's kind of like this, right? This is 5. So here what we see is that the domain is of this function is x value should be greater than or equal to 5. Is it okay? You could also find by placing x minus 5 greater than or equal to 0. You could do that. You could do x minus 5 greater than or equal to 0. Since within square root, we should have non-negative terms, right? So 0 or positive. That means x is greater than or equal to 0. Right. I'm sorry. 5, taking 5 on this side. So that is what we get. Okay. The other one here is a rational function, which is kind of 1 over x. And that has been translated 3 units towards the left side. So, okay. So we'll have a vertical asymptote at x equals to minus 3, kind of like this. If I write x equals to 0, we get positive value. And the graph will be, let me sketch here one, approximately, right? So we're just finding domain range. So these graphs are good enough. This point here is minus 3. So domain here is x belongs to real numbers where x is not equal to minus 3, right? So that becomes the domain here. The last one here is kind of complicated. We'll sketch it in two different ways, okay, in 2 steps. So what we find here is that this part, x squared, let me write here, will work like this. X squared minus 4, which is in the denominator, should be greater than 0, right? It cannot be negative since it is within square root. It cannot be 0 since we are dividing by that, right? So x squared minus 4 should be greater than 0. And what is x squared minus 4? X squared minus 4 is a parabola, right? Which is shifted 4 units right, down, right? So it's kind of like this, where this value is minus 4 and these two values, it is 0 at plus minus 2, right? Plus minus 2. As you can clearly see, the domain is this. Minus 2 and plus 2 cannot be included. So for this function, the domain is, let me write in the interval form, minus infinity to minus 2 union from 2 to infinity. Is it okay? So that becomes the domain of this function. Now we could actually write down the domain for f of x, correct? So let's do it. So we'll combine all the information which we have here on this number line. So from here we are saying it is greater than 5, right? So let's say this is our 0. Now this square root function which is in the numerator says x should be greater than or equal to 5. So let's say this is 5 here. So this says it should be kind of like this. Is it okay? Perfect. Now the other one says it is all real numbers except minus 3. All real numbers except minus 3. Okay. So that means, let's say here we have minus 3 here, right? And then everything else. Does it make sense? Okay. Let me write on minus 3 here. Okay. And the last one here says everything but not between -2 and minus and +2, right? So that means not including 2 plus and 2 minus, okay? So this is -2 and that is +2. So not including these, but everything else, everything else. So if you see, what is the intersection of all this? Well, since we have x minus 5 in the numerator, in this particular case, the only interval which is common to all is the one which is greater than equal to 5. Do you see that? Greater than equal to 5. Correct? So in this particular case, since this is everything, that one is everything greater than 2, right? So we have this thing common, and the domain for this function will be equals to greater than equal to 5. So I'll write this as 5 to infinity. Is it okay? So that becomes the domain for this particular question. Now, I could change this value and then find another function for you. So let me rewrite another function for you and let that be the question for you. So if I define a function g of x as equal to, so I'm making a very slight change. Carefully look at it. We are writing this as square root of 5 minus x. I'm just making this small change. 5 minus x divided by, I'm keeping all other things constant, same, I mean x plus 3, so that you don't have to do these calculations. And then we'll have square root of x square minus 4. Do you see? For g of x, find domain of g of x. That is the question for you. Okay? So basically the only change is this red line going to the right will now go towards the left, and then you have to write domain of g of x. Do you see that? So that's the question for you. The answer will be, you can pause the video, write down your solution, and here is your answer. So if I change it, so let me just use another ink on the same thing. So instead of going towards that side, if this thing is changed to that thing, right? So it becomes this, right? Now the common domain will be, since this is also this side, we have from 5 to 2 here, correct? Minus infinity, let's read from this side. So it is from minus infinity to minus 3, union, from 3 to minus 2, minus 3 to minus 2, and then nothing in between because this is not allowed, right? So this one actually is this side. Is it okay? Nothing in between, but from 2 to 5, right? So we get this union, not including 2 because that gives you an asymptote, but you could include 5, right? So we have 5 included. So that becomes the domain when I change the function to this one, right? So let me highlight this. Okay. So that was the test question for you. I'm Anil Kumar, and I hope it helps to form a strategy and find domain of such complicated functions. You can always share and subscribe my videos. Feel free to post questions. Thank you and all the best.